Hi everyone, sorry I couldn't be with you today. So I'm going to make a video going over the ideas in section 7.4, which is called Angle-Angle Similarity. At any moment, feel free to pause the video to try problems before I go over them, and then you can just speed up and make sure that your answers are correct. What we're going to start with today is just recalling that we had 5 ways to prove that triangles were congruent. And those were side, 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 angle, side, angle, side, angle, side, angle, angle, side theorem, and HL theorem. Similarly, we're going to have 3 ways to prove that triangles are similar. We're going to look at one of them today. But before I get ahead of myself, let's just remind ourselves, what does similar mean? Our first definition was just same shape, different size. Okay. And then we expanded that a little bit and figured out that they have congruent angles, okay, and proportional sides. Okay. And we had 2 acronyms that came up the other day, and they were corresponding angles of similar triangles are congruent, and we had corresponding sides of similar triangles are proportional. All right, so our first postulate, the only one that we're going to cover in 7.4 today, is the angle-angle similarity postulate. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So for instance, if I know that this is a right triangle, so a 90-degree angle, and I happen to know that this angle is 60 degrees, and then I have a smaller version with a 90-degree angle here and 60-degree angle here, okay? Well, of course, I can figure out that this third angle would, of course, be 30 degrees. We know that similar triangles have corresponding angles that are congruent, so these 2 triangles are similar. We didn't even really have to figure out the 30 degrees. Therefore, this similarity postulate only has 2 letters in it, angle, angle, versus, when we just studied congruence, we had 3 letters in all of our postulates. This only has 2, angle, angle. How are you going to use it? Well, one way that you might use it is in this type of example that you can see here. Tell whether the following triangles are similar. If you can find 2 corresponding angles that are congruent, then you can prove that the triangles are similar by angle-angle similarity. So, first one, let's see. We've got 62, 60 degrees. That must mean that the last angle is 58 degrees. I look over here. Do I see 2 pairs of angles that match, that are congruent? I don't. So these cannot be similar triangles. Next problem, I see 50 and 60. So there's a 50 over here in the other triangle, but not a 60. But hold on, let's subtract from 180. If we add 50 and 60 together to 110, 180 minus 110 happens to be 70. Oh, there's my second angle. So yes, these are congruent by angle-angle similarity postulate. All right, number 3, I've got 2 isosceles triangles. Are they similar? Well, let's figure out the base angles, which of course are congruent on the left. 180 minus 40 leaves me with 140, which I divide into 2, and I get 70 and 70. Well, that definitely does not match up with 75 degrees, so the answer is no. Number 4, all right, I've got 2 right triangles. So I've got 1 angle, but I really do not know anything about these other angles. I just cannot come up with 2 angles that are the same. So this is a no. This is an interesting diagram, and you're going to see a lot of this in this section of notes. The two triangles in question I've highlighted. Okay, you can see that they share 45 degrees right here. They both contain that angle. And in the blue triangle, you know a second 45-degree angle here. But I don't see anything else in the yellow triangle to really match up to. Perhaps these two lines are parallel, but I just don't know. So I really don't have enough information to determine similarity in number 5. In number 6, I've got right angles. I've got one angle. And then, of course, we've got our vertical angles. So we've got two pairs of congruent angles that match up. So we can say, yes, these triangles are similar by angle-angle similarity postulate. Number 7, I do have some parallel lines. So relationships like corresponding angles are congruent apply. So angle ABC is congruent to ARS, and angle ACB is congruent to angle ASR. So I've got angle-angle similarity. Yes, they are similar. Now I want to point out something to you. We do have the ability to see that a third angle is congruent. They share angle A. So we can actually see all three angles without even having to resort to the triangle sum theorem. Alright, next we have a proof. Now I said that there are limited proofs in the second semester, but in the next two sections you are going to see a return to proof. They will be very similar to the proofs that we did for triangle congruence with side, 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 angle, side, and of course our old friend CPCTC. But instead of CPCTC, we might want to use corresponding angles in similar triangles are congruent, or corresponding sides in similar triangles are proportional. So keep those two in mind. Alright, we're told that angle 1 is congruent to angle 2. That's our given. So I'll write that down. Here we go. We've got one angle. Now I see a larger triangle in yellow, and I see a smaller triangle in blue. And as I highlighted, I noticed that my highlighting went over angle B twice. Angle B is in both the blue triangle and the yellow triangle. So I can say that angle B is congruent to angle B by reflexive. And that quickly, I've got angle-angle similarity. I can say that triangle BED, for instance, is similar to triangle BAC. Why? Angle-angle similarity postulate. Alright, now looking here, this might have thrown you for a loop. We haven't seen anything quite like that. Prove that sides multiplied by sides are equal to products of other sides. How are we going to do that? Well, our only option at this moment is to use this, CSSTP, corresponding sides of similar triangles are proportional. This is about angles, this one, so that's going to be of no use to us. Okay. Now, can we write a statement that connects these sides so that we can eventually get to this proof? Well, we learned that you could take a side, say for instance BD, put it in a ratio with its corresponding side. So what corresponds to BD? Well, BC. And let's see, what else is in here? BC and DE. DE, let's put that on top. That's a smaller side. So what corresponds to DE? Well, CA. So I can write as the answer, as the reason for that, CSSTP. Corresponding sides of similar triangles are proportional. And then hopefully you see this. Oh wait, we can cross multiply. That's where they got that from. So BD times CA equals BC times DE. And we can actually write cross multiplication as our reason for that. All right. At this point, I would like you to try the following problems, thinking about our knowledge of how to prove triangles similar, which at this point you guys pretty much just know angle-angle similarity. Okay. If you've got two triangles where you can prove two corresponding angles similar, then you can use the idea of corresponding sides of similar triangles are proportional and set up ratios in proportions to find missing pieces of information. So try your best on that, and then I am going to direct you in our agenda to solutions for these exercises. Good luck.